Good afternoon. My name is Darius Paichys. I'm representing the VMware and happy to be here once again. I hope that I'll manage to deliver my content on time, just because this time I have a lot of information and useful information. But just before I start, some few things that you can know. First of all, I'm trying to lose today Workstation 10 license. Most probably all of you know, so that means we'll do some lottery afterwards in our stand. So make sure that who's interested to have the virtualization of their own PC, that's the brilliant tool. And as well, today it's kind of the important day to us, not just because of my slide deck, but today we're going to announce quite interesting stuff called Horizon App Delivery. And it will be live worldwide at 7 o'clock in the evening. I can give you some short intro into that. So that means, remember, like 2 or 3 years ago, we started discussion about the application delivery over the web browser. And today it goes live. And the technology, how it sits, what is the sits behind that, it will be explained. And I would say it's a game changer in the market from the application side. But I'll briefly mention during my presentation. So before I start storage sizing issues for the VDI environments and the view environments, so some information that we keep in mind. First of all, that all of you has a different environment. There's no single storage vendor that all of you has on the mind. Some of the let's say thoughts, it can be treated as a fact just because it's only my prescription and so on. But starting by that, what is important in our days, application, data, and the devices. 3 things, so that basically we're talking about end user computing. From the data, what we see that it grows quite rapidly, and we need to manage load and manage capacity. Again, from the devices, as I mentioned, so this means all devices what we have, they should be either should have either ability to use all application in your infrastructure or access the data. In the same time, Windows apps or Windows-based apps dramatically reducing in the number. So this means now it's SAS applications in the market already overpass the Windows applications by 50%, something like that. So basically keeping in mind all these things, the storage and performance and the way of delivery, it become important. And if we look at our portfolio for the end user computing, that's the one small thing. So that means in the past we have a discussion about the PCs, about the laptops, even the mobile devices. Now we are starting the discussion about the cars. So it does mean that our vision, we should deliver application to any device, and the device can be even the car. As well, what we need to have, we need to have secure data and enough performance to deliver that. And as I mentioned, that's the teeny little link down there. If you have a time, please be online at 7 o'clock p.m. today at evening. And that will be a huge announcement from us on application delivery way to any device, to any location. But as for the storage and for the view, so that means what is important in here. Beside that data that we need to deliver, we need to have an ability to satisfy user. And as long as users are satisfied, we can treat that we have a success in one or another implementation. As for that, storage, it's really important stuff. And how to size storage in the right way is because, again, we have the same issues. Either it costs a lot, either we don't have enough capacity, either we don't have enough performance. At the same time, to keep the investments on the track. And with that, so that means what we see, so we'll talk about the challenges, what is the current you or we or our customer has, and our view or vision how we can help to solve these issues with a minimal investment. And we will talk about the vSAN, or virtual storage appliance. It was already mentioned by AMC guys, by Madis today at morning, had a few slides about that, but we'll dig deep down in that, and especially in integration with the Vue environment. And starting from the Vue, it looks always complicated, just because the performance issues, the sizing, and such kind of the things. Within Vue, when we're virtualizing the Windows like a standard stuff, they need to have a hard disk drive. Yeah? And usually they're doing quite a lot of spins in there. But if we have like 10, 20, 40, 50,000 desktops, each of them tries to spin the disk. And usually what we see in our lives, that especially in the Vue environment, the performance of the storage become a critical one. Even not capacity, I would say performance. And just because there's different requirements for the storage, like antivirus, like application, like software updates. All such kind of the little things require some spins from the hard disk drives. And even if it's little tiny drive, but multiplied by 1,000 or 100, it requires a lot of storage resources. And how to deal with that? That's the question. Either to buy the expensive one, either to add SSD drives, name it. So that means all these things are required storage. Who's disagree with me? Can tell me. Again, life cycle of the Vue development. We are starting for the initial development and desktop pools, permanent, not permanent, persistent, not persistent. Again, failover, provisioning, and so on and so on. There's a lot of things what you need to keep in mind by doing the design of the storage or design of the architecture. What is the right, what is the wrong then, this question. And how we can keep the life cycle in the appropriate level that user will be satisfied. And with that, we end up to the user environment. That means they should read a Vue or the virtual desktop as a permanent one. They shouldn't see any differences. Okay? And environment for the users can be really different. So that means it can be office users, it can be advanced one, it can be namely designers who requires the quite heavy graphics, for example, marketing is, so on and so on and so on. I think that all of you has the same issues. We are starting discussion from the one type of user and end up with the, I would say, monsters who are using a lot of resources. And for each of single user, we need to provide the resources in an appropriate way. So that means not oversized, not undersized, just in right amount and right size. If we will compare the workload that we have in the data center, it pretty much, I would say, it's predictable. Yeah, we have like a normal operation. At the end of the month, for example, we have billing cycle. Yeah, the peak, it goes up, but then for the rest of the month, the workload more or less is stable. I think that all of you who has at least once saw the storage have the similar picture. But what is the difference in the Vue environment? Who tries to get? That's the picture. And the question for the storage admin and for the admin itself, who's able to handle such kind of the I/O peaks? How to size in the right way storage to handle I/O. If the organization is rich enough, we can say that, yeah, we will buy plenty of the flash disk drive or flash-based storage. We are done. Yes, you are done. But then question, how much it is that cost for to provide a desktop for the end user? Was probably a fortune as well. And with that, we are coming to storage sizing. And what we need to keep in mind by sizing the storage, it looks like a rocket science just to keep all these loads and pikes in the right way. It looks like a difficult, but we need to keep in mind. There's a lot of things. First of all, the single point of measurement is satisfaction of end user or performance by end user. That's I would say, hard to measure, but as long as users are satisfied, they will be able to work with that solution. If not, they will say, that's the crap, that's the underperforming, so that means please give me back my old desktop. It could be. Yeah? Then again, implementation. What do we need? What kind of the device we will use? Yeah? Again, size. How much space we'll give for the user. I mean, everyone in the organization would like to keep the pictures, would like to keep the movies, name it. Again, it requires storage. And with that, we are going again to the same question. What is the EO requirements for the desktop? How we figure what is needed? Yeah? By my understanding, so that means in our days, everyone is trying to guess. I think that it should be enough in that amount of the hard disk drive, that amount of service. But unless you are not a geek and not able to count each single I/O from the storage, it's really hard to predict. Again, how much of the usable space do we need to have? What is the reference architecture for that? And all these things, it's pretty hard to calculate as long as you don't have the already practice with that. And again, I will point to the same question. Most important thing, to keep budget in line and as well to provide enough I/O or performance and capacity for the end user devices. And with that, you can use some rules. But the rules not always right for your organization. That's commodity. So that means basically someone says that average of the users can read them that resources. But it's as well dangerous to implement it just because each single organization has own needs and own rules. Again, question, what we need to follow? We need to keep in mind average numbers. We need to keep in mind, again, read-write mix, just because in view environment, read-write mix, it's really different from the data center environment. And again, in view environment, what we do have, we have I/O peaks or I/O boots. For example, when the 100 desktops are booting, it requires a lot of I/O from the storage. Or as for example, if the antivirus is not properly configured on the view environment, it can kill the storage immediately. I can give you the live example from the installation that was done in the Baltics. So that's mean 100 view seats with the antivirus in virtual VM generate to the storage 100,000 I/O per second. So that means you can kill storage immediately, only with the antivirus. That means, again, it's a question, how to size the storage in the appropriate way. Even keeping in mind all these little things, what you need to do before the storage size. And with that, we're coming to the storage exercise. How we need to do that? Do we need to have a flash? Do we need to have a hard disk drive? Or what is the mix of that? And usually, user has ability to do the assessment. That's one of the best way, just to try it. But with the assessment as well, there are some risk. Because during the assessment or POCs, what we see that on the small environment, everything can fly. But when you're trying to scale it up, you're getting into trouble. That's because 10 little VMs, 10 little disks can generate small load. but if you multiply it by 100 or by thousands, the load will multiply as well by thousands and never progressive way. Again, what you need to keep in mind, Windows or operating system optimization also can change the game. Delivery, the way of the delivery as well can change the game. And as I mentioned, assessment, it's really good thing, but you need to keep in mind a lot of little things during the view size, and especially storage. And when we're talking to VDI tuning, you can tune the infrastructure quite easy. So that means with a SAM management tool, for example, as a vSphere operation, you can see what can be changed in order to improve performance, what can be changed in order to improve the capacity, and so on. But when we're talking about the VDI, it's like rocket science. Now, one user can do whatever he wants, another user can do whatever he wants, and it becomes, at the end of the day, quite messy. How to fine-tune whatever little pieces in there, little pieces in there. That's the kind of rocket science. But with that, we are coming to a bit different approach. First of all, when we ask the question, again, what storage is right to me? And on the market, there's plenty of storage vendor with whom you can deal. Most probably you're dealing with one of them, like EMC, HP, NetApp, name it. There's plenty of them. Yeah? Then it's question, how to size it properly. How much SSD drives, how much SATA drives do I need? Yeah? This is good way, but are you sure that that's the only one way? And with that, what we're trying to achieve. Again, scalability, CapEx, green, and each different organization has own need. But in same time, all of us, it's trying to keep ROE or investment in the appropriate line. And in our days, what we see the challenges that when you're using SATA or whatever, magnetic hard disk drive, in comparison with SSD, so that means SATA can bring, or magnetic drive can bring you a lot of capacity. SSD drives can bring you a lot of I/O. But then when you measure the performance, it's way better in the flash drives. But let's try to count in that way, that magnetic disk or hard disk drive, per capacity, it's quite cheap. Let's say 1 gig can cost 1 cent, 10 euro cent, name it. But the same capacity in SSD drives cost fortune. But if you'll measure vice versa, to get 1 I/O per second in magnetic drive, it costs fortune. But vice versa, in SSD drive, it costs little. Then why we not combine such both approaches into the one and get the maximal possible speed out of and capacity out of the storage? And here is simple comparison. So that means when we're comparing the performance of magnetic drive and SATA drive, we land near to almost 400 times faster I/O per second. Just to get understanding how much it's fast, if we compare that our walking speed, it's like 3 miles per or 5 kilometers per hour. Yeah. So that means by multiplying it by 400 times, we'll reach the jet speed. So, but that's the cool comparison. Yeah. So that means the same with the I/O or performance in the storage. But to choose either to walk, either to fly, SSD or HDD drive. And again, that's the cool stuff, but what to choose? What kind of the storage is right for you? And as I mentioned, what you need to keep in mind always, that I/O per SSD drive, it really costs nothing, capacity costs fortune. And vice versa, per magnetic drive, I/O costs fortune, but capacity costs almost nothing. So that means that's the right sizing should be kept in mind, and again, you should have an ability to improve on the fly either performance and the capacity. Depends on the needs that you have in the environment. Again, if we are talking about a view, most probably you need to have a lot of performance just to keep the boot storms when the virtual VMs are booting. Why not to add some SSD drives into the environment on the fly and to maintain that I/O boot storms? But if you need to store the pictures or user profiles and you don't have a space, why not to add on the fly some magnetic or HDD drives and keep that on the right size? So with that, keep in mind these two comparisons: price per I/O, SSD, best option, and price per capacity, magnetic drive, best option. And with that idea, we are going to introduce vSAN. vSAN able to leverage both things. So that means either I/O, either capacity, either combination of one and another. And beauty of the vSAN that it's really simple. Who has a chance to manage or at least once log in into the vCenter? Some of guys, yeah? So basically the vSAN is simple as that you're enabling the functionality of the virtual storage by clicking one tick mark that enables the vSAN. That's it. You don't need to care about nothing anymore. And again, so that means it's either performance, either capacity. And from the TCO perspective or return on investment, when you have an ability to choose what you need at that time, either performance, either I/O, you're able to measure on the investment, on the spendings. That's the cool stuff. vSAN itself, as I mentioned, it's already integrated into the vSphere kernel. You don't need to have nothing. No appliance, no virtual machines, nothing. It sits already in the hypervisor, ISX. Basically, tick mark, enable, you are done. vSAN leverage internal disk drives. It's been DAS. And from the architecture point of view, it's quite simple. You don't need to care about writes, about LANs, about nothing. So either you enable it, either you disable it. Simple as that. Just to get an understanding, we're not competing with the classical storage. It's add-on to the data plane pool. So that means we can leverage both of them, classical NAS SAN and virtual SAN. Why not? As some requirements in here, as I mentioned, so that means we require at least one SSD drive and one SATA drive, one magnetic drive in the environment, just to provide either performance, either capacity. From the performance and the capacity side, that's the maximums, what we can reach now with the current vSAN. 2 million IOPS, quite a number. And keep in mind that this number we can get only out of the internal disk drives that sits on the server. Maximum capacity 4.4 terabytes with the current version. Again, supported 32 hosts on the one data store and up to 3,200 VMs. I would say quite a number. But let's look how the vSAN acts in the environment and how we can leverage out of that. Some minimal requirements that we're asking to have, basically any x86 server, any of them. One of these friends, one SSD, one magnetic drive, 1G or 10G NIC, just to have an interconnection between the servers, between the nodes, as we're calling it. SATA SAS controller. Again, that's the important thing with the pass-through enabled, is because you don't need to care about the writes. SAN will do it, vSAN will do it instead of you. And SD card just to boot up ASICs or the hypervisor. That's it. Just, I have 16 minutes. For the boot device, as I mentioned, any SSD card, any drive that you're using now, you can use it in the future as well. For the flash-based drives, it's really important to understand that on the vSAN, as the front end, the staging for the read and write, we always using SSD. In conjunction with the vSphere read cache, it can be used for the read cache buffer, and as well, it can be used for the write cache buffer. So basically, we're not trying to use the magnetic drive for the first the stage information, so that at least SSD drives will act as the first point of the write for the write, and then vSAN will the stage information in the data store. And then magnetic or the hard disk drive, classical ones, you can choose whatever you want. Better capacity, better performance, it will use for the staging of the information. And vSAN will decide instead of you what kind of the information we should keep on the read cache or the SSD drives, what kind of information should be the staged into the magnetic drives. As I mentioned, for the network, it's also important to get understanding that as long we should have some interconnection between nodes. As a minimum requirements, it's 1G. It's for the small environment. We have recommendation for the 10G connections. And you can connect starting from 3 up to the 30 nodes, 32 nodes, into the one data store. I already quickly have mentioned that either you can build a vSAN on your own environment and leverage that on servers, or you can buy a pre-built node for our friends, basically Cisco, Dell, Fujitsu, IBM, name it. All of them already has it on the portfolio. But you can leverage your existing infrastructure if you will keep in mind that all these components are in place or in the server. So how it works? And just to understand the benefits of the vSAN, we need to understand why we leverage vSAN, especially in view environments for the intensifier or for the performance capacity, as well to classical data center. First of all, I already mentioned, vSAN is quite simple. Just turn it on and you are done. And it already sits on VM kernel. You don't need to do nothing. As for resources, vSAN has limitation. Maximum 10% of the CPU and memory will be allocated for the vSAN operations. Maximum, no more. So this means just to keep the enough power to daily based operation or to serve the VMs. Some requirements, of course, vSphere 5.5, just because it already sits in there. Local storage with SSD hard disk drives and network. And vSAN pulls automatically all these drives into the data store presented in for the vSphere host as a one shared storage. But then again, how the SAN will act or will deal with the VMs as long as there is no writes, no groups, nothing. vSAN is derived by the policies. And that's really important, not only for the view environment, as well for the data center. Especially in the view environment, you can say that for that particular organizational unit, I need to provide maximum performance. For this particular user, I need to provide maximum capacity. And the vSAN will take care about the rest. So basically, the VM will be stored on the right place of the vSAN. Either it will be SSD, either it will be magnetic drive, as long as the VM is in line with the policies that you said before. And you will ask me most probably, how we will be sure that the information that we have is protected. And vSAN acts in how the hell it was there? vSAN acts quite simple. So that means information are stored at least twice on 2 different nodes. And as I mentioned, so that means it policy-based storage or management. vSAN pull all the disk from the nodes or from the servers into the one virtual pool. And then based on the policy, vSAN will keep at least 2, it can be n plus 1 protection, will keep 2 copies on the different nodes or on the different servers. And then, as I mentioned, SSD, it already acts as a read-write buffer. All information either will sit on SSD if it's actual, either it will be destaged to the magnetic drives if it's not actual anymore. And as well, it can be redeemed or bring it back to the SSD when user will start to request all the information. So basically, the vSAN will monitor VMs by the policies that are set, and you will get the information is the VM is compliant or not. And the vSAN will do the rest of the job instead of you. So what you need to set only policies in the storage environment. Simple as that. What we're treating as the vSphere object, in that case, all 4 files that you know from the hand. Home, VM home, that means the file of the VM itself, VM swap, VM decay, drive, and snapshots. That we're treating as the VM objects. And these objects as well can be placed in different vSAN network groups or disk groups, just to keep in mind set policies that are compliant in your environment. Cool stuff, isn't it? So this means you don't need to do nothing. So this means set policy, install the drives, and restings are done by the vSAN. Scalability and understanding of the vSAN architecture, as I mentioned. So that means vSAN, in order to have a protection, it's built on the disk groups. So that means one disk groups should contain maximum 7 drives, 6 magnetic or hard disk drives, 1 SSD. And it can be filled as much as node can hold. So basically, we are talking about the DAS or direct attached storage. No writes, nothing. vSAN will pull those resources into the one storage. So this means we'll leverage SSD drives as a read and write buffer, and then we'll do the destaging by the policy in here. So in that way, we are protected from the disk failure. We are protected from the node failure. And the vSAN, in case of the node failure, will wait for 30 minutes. It's default of the vSAN. You can change it later on. In order to be sure that someone is do not plug either network card, either hard disk drive or something like that. If after 30 minutes, drive or node will not appear in the SAN cluster, vSAN cluster, then vSAN will treat that, yeah, I lose the node, I will start do the replication on the another node just to have a data at least on 2 nodes. Yeah? As well, for the scale up, if you remember that we had a discussion, so that means how to scale by the request of the IT environment. So that means if you need more performance, basically more I/O, you can add on the fly SSD drives. And the vSAN will scale automatically the environment. So that means he will see that you have now on the vSAN storage more I/O capabilities. At the same time, if you need more capacity, you can add just magnetic drives. And again, vSAN will do the rest job for you. Again, scale out. And beauty of the vSAN that you can scale out quite linearly. So this means as long as you need the performance or capacity, more nodes, more drives you're adding, you're scaling both things, and capacity and I/O. It depends on the needs. So that means you have a chance to choose what kind of the priorities you have or should have in the storage. And comparing the price of the drive in the storage and the drive in the server, it's a bit different. So that means you have a possibility either to scale linearly by adding the nodes or by adding the drives into the nodes. And as I mentioned, so that means why it's brilliant for end user computing, especially for the end user computing. First of all, SSD drives can hold peak of I/O requirements or boot storms. And in conjunction with the read cache buffer that you have ability to enable in the vSphere, vSAN will be able to hold or keep the I/O on the set policy level. As well, for the hard disk drive or magnetic drive, so that means you can add a capacity. And if you remember that I have mentioned that we're not competing with the classical storage. The classical storage can be added to the vSAN pool, and vSAN can act as a buffer for the storage. So that means if you have already old storage or storage with not enough performance, you can put vSAN in between just to handle, for example, I/O or to add more capacity. And in that way, so that means you can choose the protection level N+1, the fault tolerant, linked clones, and all standard functionality. It works out of the box. One exception in the vSAN, you are not able to use VDP, or basically you're not able to shut down the host when they are not used, just because then information that it's kept on the server will remain unprotected. So that means, and we are not following the VM. As long as you can do the vMotion of the VM on the server side, we are not following with the data in backend side. So basically 10G it's enough to request the data from any server. In that case, as I mentioned, so that means vSAN, it's absolutely brilliant for the view environment by keeping two things: I/O in the right level and capacity in the requested level. And you can maintain it on the fly. That's the beauty of the vSAN. If you don't have enough performance, just add one single SSD drive and you are done. Yeah. With that, I was really quick one. So that means usually it takes like more than 1 hour to cover this one. But as long as time is limited, now I'm ready for the questions.
What about CPU performance? It should take some CPU time.
Yes, vSAN it's taking some CPU time and some memory. Two things are used by vSAN. But we already have mentioned that we have a limitation. No more than 10% of the host will be, or the host power will be used by SAN. It can be less, but no more than 10. And again, just to get understanding that vSAN has a protection, vSAN will write in the 2 parallel hosts at the same time to the SSD drives. And as long as they get acknowledgement for both of them, that the information is on my SSD written twice, then we will get confirmation that yes, I have the information written into the storage. And then vSAN will destage the information, whatever it's needed, and based on the policy.
What will happen if the 32 node hosts are full, if you need addition on 33rd?
Good question. If you have 32 nodes, it's maximum configuration. That means it's one data store. Then you need to build another data store by now. In the future, we will give you ability to expand the current data store. But then at the end of the day, you need to have 2 separate data stores. That's it. Okay, if there's no question, thanks for your time. I will remind that I still have a Workstation 10. Guys, it's like almost 300 euros in here. Workstation 10, please leave your contacts on my table and we'll do the lottery within 15 minutes. So, thanks once again, and I'm ready to answer your question outside.